Okay, you guys, we are going to learn how to do orbital diagrams or orbital notation. So we did notes on it, but we haven't actually saw how to do it yet. So what you're going to need is you're going to need a periodic table. And so the element they give you, you're going to look it up. Just like we do on electron configuration. And what you're going to do is you're going to write basically the electron notation, and you are going to also show where the electrons are and which way they're spinning. So if we were to write the electron configuration for silicon, let's do that here, and then I'll show you how that translates to an orbital diagram. So you would have 1s2, 2s2, 2p6, 3s2, and then to get to silicon here, you would have 3p2. Okay? For orbital diagrams, they're the same, except for you're going to draw lines for the orbitals. And remember, an orbital can hold 2 electrons, and the electrons are spinning in the opposite direction. So that means I'm going to draw a line, and underneath that line I'm going to write 1s. The 2 is 2 electrons, so I'm going to show the electrons spinning in opposite directions with 2 arrows that are going in the opposite way. The same thing for 2s, has 2 electrons. Now the 2p has 6 electrons, so that means I need 3 lines because each orbital can only hold 2 electrons. Notice I took the long way about it, but remember, every orbital has to have 1 electron before you can start pairing them up. 3s has 2, and 3p has 2. So I'm going to put my first one there, my second one there. I can't put them in the same orbital because each orbital has to have 1 electron before we start pairing them up. I kind of try to relate this to, say you got a new house. There's 3 kids in your family. If you move into a 4-bedroom house, your parents are going to have 1 bedroom, right? And then each of the kids is going to take their own bedroom. You guys aren't going to share unless you run out of bedrooms. So that's kind of how I like to look at it. Let's try another one. This time we're going to do chlorine. So let's first write the electron configuration for chlorine. So 1s2, 2s2, 2p6, 3s2, and then 3p, and we're doing chlorine, so 1, 2, 3, 4, 5. So once you have done a few of these, the next ones are pretty simple because they're very similar. So our 1s and 2s are full, so are our 2p, 3s. Now our p has 5, so that means we're going to do 1, 2, 3, 4, 5. So one guy down here will be lonely, but the other guys will have pairs. Okay, I'm not going to bother you and bore you with a whole bunch more examples. If you don't understand, let me know, and I'll help you.